Hi, welcome back to our class in chemistry. Today, we will discuss about the nomenclature of the hydrocarbons. I asked you in your assignment last time that you are going to read about the nomenclature of hydrocarbons. So let's start with the naming of the alkanes. We have discussed about the alkanes last time that in naming them, the name ends in A and E. For example, those alkanes with one carbon atom is called methane. Those with two carbon atoms is called ethane. Those with three carbon atoms is called propane. With four carbon atoms is butane. With five carbon atoms is pentane. Those with six carbon atoms, it is called hexane. Those with seven, they are called heptane. Those with eight carbon atoms is called octane. Those with nine is called nonane. And those with 10, it is called decane. There are also hydrocarbons which contains 20 carbon atoms. And this containing 20 carbon atoms is called icosane. And those containing 30 carbon atoms is called triacantane. Now, there are isomers formed when the hydrocarbon or when the alkane contains already 4 carbon atoms. Say for example, the butane, when one of the carbon atom is placed as a branch to the second carbon atom, it becomes isobutane. Or you may call it 2-propane. Now, in pentane, if one of the carbon atoms is placed as a branch to the straight chain of 4 carbon atoms, so the name of this isomer is isopentane. Otherwise, it is called 2-butane. Now, what do we mean by isomer? By the way, isomers are those compounds having the same molecular formula but different structure. There are also alkanes in cyclic structure. They are called cycloalkenes. Now, how many carbon atoms are needed in order to form a cyclic compound? If you're going to have 3 carbon atoms, then you can form already a cyclic structure. So the least number of carbon atoms in order to form a cyclic structure is 3. So for a cycloalkane, there is what we call cyclopropane, because propane has already 3 carbon atoms, and when placed in a cyclic structure, it is called now cyclopropane. Now, if there are 4 carbon atoms in a cyclic structure, it is called cyclobutane. If there are 5 carbon atoms placed in a cyclic structure, it is called cyclopentane. If there are 6 carbon atoms in a cyclic structure, it is called cyclohexane, and so on and so forth. So those are some examples of the common alkanes and the cycloalkanes. Let's go to the nomenclature of alkenes. Now, the alkenes are actually unsaturated hydrocarbons where the carbon atoms are joined by double bonds. Now, in naming the alkenes, the name ends in E and E. That's why it's alkene. So, E and E. Now, the least number of carbon atoms to exhibit the double bond is at least 2. So you can see the double bond between the 2 carbon atoms. That's why the first member of the alkene family is what we call ethene. So if there are 2 carbon atoms, the alkene is called ethene. If there are 3 carbon atoms in which the double bond occurs between carbon 1 and carbon 2, then it is called propene. If there are 4 carbon atoms and the double bond occurs between the first carbon atom and the second carbon atom, it is called butene. However, if you are going to transfer the double bond between the second carbon atom to the third carbon atom, this is now what we call symmetrical butene. The symmetrical butene is already an isomer of 1-butene. 1-butene means that the double bond occurs on the first carbon atom. That symmetrical butene, the double bond occurs already in the second carbon atom. Why is it that is called symmetrical butene? It is because if you are going to cut between the double bonds, what you can see at the left is 2 carbon atoms, and what you can see at the right is also 2 carbon atoms. So they are symmetrical. If there are 5 carbon atoms and the double bond occurs in the first carbon, this is what we call 1-pentene. Now, if you move the double bond to the second carbon atom, this can be already an isomer of 1-pentene, and this is called 2-pentene. If there are 6 carbon atoms, it is called hexene. That if the double bond occurs at the first carbon. But if the double bond occurs at the second carbon, it is called 2-hexene. Now, if the double bond occurs in the third carbon atom, it is called 3-hexene. Otherwise, this is also called symmetrical hexene. Why? Because at the left of the double bond, you have 3 carbon atoms, and at the right of the double bond, there are also 3 carbon atoms. Now, there are also cyclic or cycloalkene. I said a while ago that at least 3 carbon atoms can already exhibit a cyclic structure. For the cycloalkene, you have their first carbon, you have the double bond joining to the second carbon. The second carbon joined to the third carbon, back to the first carbon, you have it there single bonds. So the name of this cycloalkene is called cyclopropene. If there are 4 carbon atoms and it is in a cyclic structure and there is the presence of the double bond, then this is called cyclobutene. If there are 5 carbon atoms in a cyclic structure and there is the presence of a double bond, then this is called cyclopentene. If there are 6 carbon atoms in a cyclic structure and there is the presence of a double bond, then this is called cyclohexene. Now, there are also what we call polyalkene. When we say polyalkene, these are alkenes containing more than 1 double bonds. So if there are already 2 or more double bonds present in a structure, you are going to name this alkene by designating the location of the double bonds. For example, in the case of a pentene, you can place a double bond between the first carbon and the second carbon. And also, you can place a double bond between the 4th carbon and the 5th carbon. So, if you're going to look at the structure now, you have C, double bond C, single bond C, single bond C, double bond C. Okay? So, the double bonds are situated at the terminal carbons. Now, how do we name this compound? The presence or the location of the double bonds are in the 1st and the 4th carbon. So, the name of this alkene is 1,4 pentadiene. Why 1,4-pentadiene? 1 and 4 are the locations of the double bonds. Penta because there are 5 carbon atoms. Di because there are 2 double bonds. And in because it is an alkene. I will give you some more examples in my notes that I'll be sending you later. Let's go to the cycloalkenes because there can also be more than one double bond present in the cyclic structure, especially in the cyclohexene. In cyclohexene, we can have 3 double bonds. If you're going to place the double bond in the cyclic structure of cyclohexene, suppose there are 3 double bonds present, so that the locations of the double bonds are in carbon 1 and 2, carbon 3 and 4, carbon 5 and 6. So how do we call the name of this cyclic structure? Now, we know that the locations of the double bonds are in carbon 1, carbon 3, and carbon 5. So, you have 1, 3, 5, cyclohexatriene. Why triene? Because there are 3 double bonds present in the cyclic structure, which is an alkene. Let's go to the nomenclature of the alkynes. We said that alkynes are compounds or hydrocarbons in which the carbon atoms are joined by triple bonds. The names of the alkyne end in Y-N-E. That's why it's ine or alkyne. Now, at least 2 carbon atoms can exhibit already an alkyne. So, the first member of which is what we call acetylene or ethyne. We have carbon 1 is joined to carbon 2 by 3 bonds or by a triple bond. So, we have C, triple bond C, is what we call ethyne. Now, another one, if there are 3 carbon atoms and the triple bond is exhibited or placed between carbon 1 and carbon 2, so this is now called propyne. If there are 4 carbon atoms, then the triple bond is placed between carbon 1 and carbon 2, then the name is 1-butyne or normal butane. If we're going to place or move the triple bond between carbon 2 and carbon 3, then the name is called 2-butyne or symmetrical butane. If there are 5 carbon atoms and the triple bond is placed between carbon 1 and carbon 2, so this is called 1-pentyne or normal pentyne. If there are 6 carbon atoms and the triple bond is placed between carbon 1 and carbon 2, it is called 1-hexyne. Now, if we place the triple bond between carbon 3 and 4, so you have it there, symmetrical hexyne. Why? Because the triple bond, if you're going to bisect that, at the left there are 3 carbon atoms and at the right you have also 3 carbon atoms. That's why it's symmetrical. There is no cyclic alkyne. So those are the names of the alkane, the alkenes, and the alkynes. Another group of the hydrocarbons is the aromatic hydrocarbons. Now, for the aromatic hydrocarbons, these are hydrocarbons which exist in a cyclic structure or in a ring-like structure. Compared to the aliphatic hydrocarbons, we said that the aliphatic hydrocarbons are those hydrocarbons in which their structure is in an open chain. Now, in the aromatic hydrocarbons, their structure is in a cyclic or in a ring-like structure. The characteristic of the aromatic hydrocarbons is that they possess odor or aroma. That's why aromatic. And this odor or aroma may be pleasant or unpleasant. Now, how do we know that it has already a ring-like structure or it is qualified to be called aromatic? Now, we have discussed a while ago that the structure of the cyclohexene with 3 double bonds in it, we have the 1,3,5 cyclohexatriene. This is actually what we call benzene. If we try to recall the structure for the first member of the aromatic hydrocarbon, which is the benzene, this is actually a derivative, or this is actually that of the 1,3,5 cyclohexatriene. According to Kekule, when he proved the structure of the benzene, you have these pi bonds, or the double bonds in the cyclic structure of the hexatriene. These double bonds present there, one of the bonds of these double bonds can move within the ring, meaning it has the tendency to move from one carbon to the next carbon. So, in this case, the 1,3,5 cyclohexatriene can resonate, or the pi bonds, can resonate, meaning they can move around the structure of the cyclohexatriene. Now, this is what we call the resonance structure. And this 1,3,5 cyclohexatriene is what we call the benzene. Now, if you're going to bisect the benzene, you have there a symmetrical structure. When we say symmetrical, you have the same structure after dividing it into 2 equal parts. So, if you call carbon 1 as alpha, the carbon 2 as beta, carbon 3 as alpha again, carbon 4 as beta again, carbon 5 as alpha again, carbon 6 as beta again, and then you bisect from carbon 1 to carbon 4. Draw a line passing through the center so that you can see that the bisected parts are the same or equal. There are some examples of these aromatic hydrocarbons. Number 1 is the benzene. Now, the benzene is known as the parent compound of all the aromatic hydrocarbons. Now, if this benzene has a substituent placed in any of the carbons, a substituent is placed in one of the carbon atoms along the cyclic structure, such as methyl group. So this is called methyl benzene, commonly known as toluene. Another aromatic hydrocarbon is if a substituent like hydroxyl is being placed or attached to the benzene ring, then it is called hydroxybenzene, or otherwise known as phenol. Another aromatic compound is when a nitro group is attached to the benzene ring. Now, if you have the nitro group attached to the benzene ring, this is called nitrobenzene. Okay? Now, if you have another aromatic compound such as the amino group or NH2 is attached to the benzene ring, then this is called aminobenzene or aniline. Now, if we're going to fuse 2 benzene rings, the aromatic compound is called naphthalene. If we're going to fuse 3 benzene rings, it is called anthracene. And if we're going to fuse 3 benzene rings such that one benzene ring is superimposed to the second benzene ring, then this is called phenanthrene. If we are going to fuse 4 benzene rings, this is called tetracycline. And if we're going to fuse 5 benzene rings, and one of which is superimposed above the 4th benzene ring, this is called benzpyrene. Now, all these aromatic hydrocarbons are, by the way, carcinogenic, meaning they are cancer-causing. Now, the benzopyrene is contained in the cigarette smoke. And this benzopyrene is that substance responsible for the cancer causing. This benzopyrene is a substance that can cause cancer. So those are all about the hydrocarbons, the aliphatic and the aromatic hydrocarbons. Another group of the organic compounds is the alcohol. This alcohol, by the way, is a derivative of the hydrocarbons in which one of the hydrogen atoms is replaced by a hydroxyl, or this is also known as the analog of water in which one of the hydrogen atoms is replaced by an alkyl or an aryl group. Now, what is meant by alkyl? By alkyl, it means that this is an alkane deficient in hydrogen atoms. So, for example, the alkane, which is methane. The methane is an alkane. If we're going to remove one of its hydrogen atoms, then there will be only 3 hydrogen atoms left. So, this is now called methyl, which is an alkyl. So, deficient already in hydrogen atoms. Now, what do we mean by aryl? By aryl means it is an aromatic group, such as the benzene. Now, the alcohols, by the way, has a general formula ROH. And the functional group of the alcohols is the hydroxyl or the OH. The name of the alcohols ends in OL. So, for example, if there is one carbon atom, then the name is methanol. Why metha? Because the root word there is methane, a hydrocarbon alkane, methane. And replace the E there with ol, so you have it there, methanol. If there are 2 carbon atoms, it is called ethanol. If there are 3 carbon atoms, it is called propanol. If there are 4 carbon atoms, it is called butanol. If there are 5 carbon atoms, it is called pentanol. If there are 6 carbon atoms, it is called hexanol, and so on and so forth. So that if you have 10, it is called decanol. Starting from alcohol with 3 carbon atoms, there is already an isomer. Why? Because you can place the hydroxyl group at the 2nd carbon atom so that the structure would look like this. CH3 bond CH, OH bond CH3. Notice that the 2nd carbon atom contains the hydroxyl group. In this case, this is what we call the isopropyl alcohol. Now, the isopropyl alcohol is known as the rubbing alcohol. The ethyl alcohol and the isopropyl alcohol are both antiseptic, and they can be used as microcidal, bactericidal, antimicrobial, because they have this disinfectant property. But if you're going to choose which is better to be used as a rubbing alcohol, it is the isopropyl alcohol, which is used as a good rubbing alcohol, not the ethyl alcohol. Now, what is the importance of knowing this alcohol? By the way, the ethyl alcohol is present in the beverages, and the concentration of the ethyl alcohol in beverages is called proof. The proof implies that it is double its percentage concentration present in the beverage. For example, if the beverage is marked 80 proof, then that beverage has 40% alcohol. For example, the Tanduay rum is marked 80%, so that Tanduay rum has 40% alcohol in it. Or the vodka is marked 92 proof. That means it's 46% alcohol. And the rest of the component of this beverage are, of course, the liquid part, the water, and other spirits of the alcohol placed there. Now, what are the properties of alcohol? The alcohol, by the way, are soluble in water. Just like the ethyl alcohol that we perform in the laboratory, it is soluble in water. But as the number of carbon atoms increases, then the solubility of the alcohol decreases. Meaning, as the number of carbon atoms increases, it's no longer soluble in water. Another property of alcohol is that its boiling point is abnormally high as compared to that of the hydrocarbons with the same number of carbon atoms. On the other hand, the aromatic alcohol like phenol, this has a slightly acidic property. That's why when we performed experiment on alcohols and phenols, you notice that the phenol is releasing the carbon dioxide when it was reacted with sodium bicarbonate because it has a property of being acidic. And this aromatic alcohol, like the phenol, this phenol is slightly soluble in water. Now, there are those alcohols which contains two hydroxyl groups, and these alcohols are called diol. For example, we have the ethane diol. So you have the structure of ethane diol is CH2OH, single bond CH2OH. And there are also alcohols which contains three hydroxyl groups. An example for this is the triol glycerol. So the glycerol has the structure CH2OH, CHOH, and CH2OH. Notice the presence of the three hydroxyl groups in the structure. Now, where can we find this glycerol? This glycerol is found in the cosmetics, by the way. This is also incorporated in some medicine because this has a sweet taste and it is not toxic. And we will discuss the third group of organic compounds, which are the aldehydes and the ketones. Now, the aldehydes and the ketones are grouped together because they have the same functional group. And the functional group of the aldehydes and the ketones is what we call the carbonyl group with the structure C-double-bond-O. Now, the aldehydes differs from that of the ketones because the carbonyl group is found at the terminal carbon of the structure, while that of the ketone, the functional group is found at the middle carbon or in between two carbon atoms. So this is the difference between aldehydes and ketones. Now, in naming the aldehydes, the name ends in -al. For example, if there is one carbon atom, it is called methanal. If there are two carbon atoms, it is called ethanal. If there are three carbon atoms, it is called propanal. If there are four carbon atoms, it is called butanal. If there are five carbon atoms, it is called pentanal. If there are six carbon atoms, it is called hexanal. On the other hand, the ketones, how are they named? The name of the ketones ends in on or O-N-E. And the simplest ketone, by the way, is called the acetone, or this is propanon. If there are four carbon atoms, it is called butanon. If there are five carbon atoms, it is called pentanon. If there are six carbon atoms, it is called hexanon. Now, what are some properties of these aldehydes and ketones? The aldehydes, by the way, can oxidize the potassium permanganate or the permanganate. As you notice in our experiment, that when the formaldehyde, or that is actually the methanol, it oxidizes the potassium permanganate by changing the color from a purple into a colorless one. And when it was reacted with the Fehling's reagent, the formaldehyde turned light yellow to orange. However, the ketone or the acetone is not a good oxidizing agent, and it does not react with the Fellings reagent. The aldehydes, as the number of carbon atoms increases, the odor becomes pleasant, meaning as the carbon atoms increases, the more fragrant the scent is. So, while the ketones, as I have said, they are also possessing aroma like the acetone, or it possesses an odor like the acetone. However, as the number of carbon atoms increases, there is also the change in odor. So those are some examples of the aldehydes and ketones. If you try to recall the results you have in the experiment, then you can see that the aldehydes are good oxidizing agents. They can reduce the Fellings reagent, while the ketones or the acetone cannot. So those are all for today. At least we have discussed briefly the three groups of organic compounds, from the hydrocarbons, the alcohols, the phenols, the aldehydes and ketones. I will include these topics for our final exam. In the schedule for the final exam, it is on Monday, this coming Monday. Now, if you agree, then we will have it on Monday. However, if you will say we can have it on Wednesday or Friday, then I will follow your suggestion. Okay, just make a comment about the schedule of the final exam for our Chem 101 lecture on this YouTube channel. I will just check it. If majority of you will say or agree to have it on Monday, I will give the exam on Monday. But if majority of you will say Wednesday, I'll do it on Wednesday. Or if majority will say Friday, then I will give it on Friday. So that would be all. Good luck for our final exams. But for the laboratory, surely and certainly I will give it on Friday. That would be all, and this is your teacher, Professor Nisitas Ruiz of Holy Name University.